Um, Good morning. In this video, which is going to go over a basic introduction into limits and how to evaluate them analytically and graphically. So, here's a simple example. Let's say, if we want to find the limit as x approaches 2 of the function x squared minus 4 over x minus 2. So how can we do? So one way is to use direct substitution. If we plug into, notice what will happen. 2 squared is 4. 4 minus 4 is 0. So basically, 0 is over 0 is undefined, which we don't know what value that represents now. Sometimes you could find a limit by plugging a value that close to 2, and that's what you want. That's what you want to do. You want to plug in a number that close to 2, but not exactly 2. So for example, call this f of x. So let's calculate 2.1 to get a positive answer. 2.1 squared minus 4, that's about 0.41, and 2.1 minus 2 is 0.1. So this is going to be 4.1. Now, what if we pick a value that's even closer to 2? Example, 2.01. Bagong example kasi mas malapit nga siya sa 2. So if we type this in the way you see in your calculator, you may have to put this parenthesis. You should get 4.01. So notice what's happening as we get closer and closer to 2. The limit approaches 4. So we could therefore say that the limit as x approaches to 2 of this function is equal to 4. And this technique works for any limit as long as you plug in the number that's very close to whatever this number is, but not exactly the number. If the limit exists, is going to converge to a certain value. Now, sometimes you have to use other techniques to get the answer in this particular example. Let's say we could factor x squared minus 4. You can write it as x plus 2 times x minus 2. For now, we need to rewrite the limit expression until we replace x with 2. Now, notice that we can cancel x minus 2. So, this term is gone. We can now use direct substitution. We can use now direct substitution because the x minus 2 factor was giving us a 0 in the denominator, which we don't want. So now, all we need to do is to find the limit as x approach 2. X plus 2, so now we can replace x with 2, and 2 plus 2 is 4. And so, that's the limit is approaches value. Now, let's look another example. What is the limit x? What is the limit x as x approaches 5 of x squared plus 2x minus 4 here? So notice that we don't want a fraction. We're not going to get a 0 in the denominator. So for a question like this, you can use direct substitution. So there are different techniques we can use to get the answer, but we are going to use direct substitution. So all you got to do is plug in 5. So it's going to be 5 squared. 5 squared plus 2 times 5 minus 4. So that's 25 plus 10 minus 4, and 25 plus 10 is 35 here. 35 minus 4. So the limit is going to be 31, and so that is the answer for this example.
So my topic is special limits. So on the left side, you can see the basic special limits, which is the first will be the sine x over x is equals to 1, and all of this will be limits that are x approaching 0. So sine x over x is equals to 1, 1 minus cosine x over x is equals to 0, and e with an exponent of x minus 1 over x is equals to 1. So we can check it on the decimals. X, we can see that approaching 0 is 1, and the second, approaching 0, it is 0, and the third, approaching 0, it is 1. So these are correct. So let's move on to examples. Actually, we can evaluate this using tables of values, but here are some steps that we can use. Multiplying the numerator and denominator by similar expressions, factoring either the numerator, denominator, or both. Then lastly, splitting the fraction as a sum, difference, or product of 2 or more fractions. Then let's move on the examples. So I have 3 examples here. On the right. So I have prepared it on the Jamboard. So this is the first one. On this first one, we can use the factoring the denominator and splitting the fractions. So we can do this sine x plus 2, then we factor the denominator plus 3 x minus 3. So the next steps will be we will split it. So sine times 1 x minus 3. In this step, we can immediately cancel this part, and we can substitute the negative 3 on this part. So there, you will see that it's equals to 1. So on the first part, the answer will be, let's check. Let's put here that it was negative 1 over 6. Well, on the second, we can use example. Then the second example will be this. So negative 1, 6, let's check it on decimals. So approaching negative 3. So approaching negative 3, it's over here, so it is right. So for the second example, we can see here we can use, on the second example, we can see that the 5 and the 15 can be cancelled, so this 1, this will be 2. So we can immediately conclude that. So And this limit, in this function, we can see that x is approaching 0, so we can use the formula a while ago. So here we can conclude right away that this is 1/3. So let's check it on decimal. So here, so approaching 0, so it's over here, so it's also right. Then on our third example, here, on our third example, we can simply use substitution. So sine 6 squared minus if you will calculate it, it is equals to if you calculate it, it's equals to 0. So let's check it on decimals. So the 6 will be 0. So we got the correct answer. That's all special limits.
Good morning. In this video, we're going to find the slope of the tangent line by using the definition of the derivative. In this problem, we're being asked to find the slope of a tangent line to the function f of x equals x squared plus 1 when x equals 3. And let's start by writing out the definition of the derivative. So, the definition is the limit as h approaches 0 of f of x plus h equals f of x divided by h. So, this is the definition. And now, how do we use it now? We have function, so we're going to plug these values into the function, and then we also have an x value, so we can plug that in for every x we see. So let's start with, first of all, let's plug into this x's. So this will end up being the limit as h approaches 0 of f of 3 plus h minus f of 3, all divided by h. Now, we just plug in this 3 plus h into every x we see. So we just cram it in for x, and the same thing here, we take this 3, and we cram it in for x. So let me show you what I mean. So this is equals to the limit as h approaches 0 of 3 plus squared. So I took that 3 plus h and I cram it into that x plus 1. So that's the first part here. Then we have to subtract the next part, so minus. And this is still divided by h. And now we just have to simplify. To do this is just a limit. We've learned how to do lots of limits, ones that are somewhat similar to this. So let's just go through the process. This is going to be the limit as h approaches 0. Let's expand it. It's going to be 9 plus 6h plus h squared plus 1. So that's the first bit here. Minus 9 minus 1 divided by h. All I did is to expand this term, and I distributed this negative sign. We are going to cancel. We have plus 1 and a minus 1, plus 9 and a minus 9. And now let me just rewrite this, just so we can see what we're left with. We're left with a 6h plus h squared divided by h. And now we can factor an h out of the numerator. So this is the limit as h approaches 0 of 60 times h. Factored out an h divided by h, and now I cancel this h's, and this is equal to the limit as h approaches 0 of 6 plus h. And now, we know from our limit property, we can plug this 0 in for h and just solve our limit. This is going to be equal to 6 plus 0, which of course is just equal to this. We ended up to number 6 to tell us that the slope of a tangent line, remember that this is a derivative, it tells you the slope of a tangent line to this function, but the function used when x is equal to 3, we already plugged the 3 in, so the slope of that tangent line is 6. Here is the function x squared plus 1, and what we're saying is when x is 3, the slope of a tangent line to this function is 6. So the slope of this tangent line is 6. That's we figure out by taking this derivative.
Hello guys, this time we will be discussing about the limit definition of derivatives. So f prime of x is equal to the limit of the function f times the quantity of x plus h minus f of x divided by h as h approaches 0. So let's say, for example, if f of x is equal to x squared, what will be its derivative? So basically, we will find the derivative of this function using the limit process. So first, just simply replace x by x plus h. So this will now become x plus h squared. And copy this, f of x as the given is equal to x squared. So it will become minus x squared divided by h. For now, we will need to expand this to do the FOIL method later. So it will be x plus h times x plus h minus x squared x squared divided by h. Oops. And now to use the FOIL method. It will be the first term x times x is equal to x squared, and the outer part x times h plus xh, same as the inner part, another xh, and the last term h times h is equal to h squared. Copy this, minus x squared divided by h. So now, as you can see, x squared minus or negative x squared can be cancelled out. So let's cancel this. And the 2xh can be added up, and now it will become 2xh plus h squared divided by h. Next, we need to factor out the h in this function. What we do is get the GCF. I mean this h. 2xh divided by h is equal to x, and h squared divided by h is equal to h. And then divided by h. Cancel this h. This 2 can be cancelled out. Cancel. So the f of x will now be equal to x plus h. And since in the formula, h approaches 0, so let's replace the h with 0. 2x plus 0. So the f prime of x is now equal to 2x. So if the function given is equal to x squared, then the derivative of this function is equal to 2x. So, but to tell you, there is a shortcut to do this. Let's put the boundary and use the same example. F of x is equal to x squared. For the shortcut, just bring down this exponent 2 at the base of the x, and it will become 2x, and copy this to the same exponent. But this time, just decrease it by 1. So it will become 2x squared minus 1. So the derivative of the function x squared will now become 2x. Same as this. It's the same as this one. It's easy, right? So that's it. Thank you.
Good day to everyone who is watching right now. Today I will show you the basic differentiation rules: the constant, constant multiple, sum and difference, and power rule. So let's start with the constant rule. So the constant rule is the simplest differentiation rule because it states that whatever real number or ordinary number you have, it is always equal to 0. F of x is equal to 5. So why is that? Why is the derivative equal to 0? This is because, as you can see, f of x is just a straight line and there is no slope or curve found. So it is always equal to 0. So for example, y equals to 7. So as you can see, it's just a number, a constant number. So it is automatically 0. The same with our second example, f of x is equal to 0. It is equal to 0. And negative 8 is equal to 0. There's no difference in the fourth example. This is because, although it is written like that, it is still acting as an ordinary number. Thus, it is equal to 0. Power rule say that f of x equals to x to the 5th power. To find its derivative, take the power 5 and bring it in front of the x, and then reduce the power by 1. Okay, so in this example, the power becomes a 4. That gives you derivative of f of x is equal to 5x to the 4th power. So let's try that. X to the 5th. It says that it should move to the front, so 5x, and then with the power is reduced by 1, so 5 minus 1 equals 5x. 5 minus 1 is equal to 4. So this is the final answer. So the same applies for a positive, a negative, or a fraction, the constant multiple rule. So what if the function you're differentiating begins with a coefficient or a number before the variable? So it makes no difference. A coefficient has no effect on the process of differentiation. You just ignore it and differentiate according to the appropriate rule. The coefficient stays where it is until the final step when you simplify your answer by multiplying by the coefficient. So you can see by the example, y equals 4x to the 3rd power is equals to 12x squared. So how did that happen? So 4x cubed. So power rule, you can see. So move this to the front. So 4. Okay, 3, 4, like that, and then x, 3 minus 1. So we can see that pwede siya i-multiply. So we can multiply it. So 3 times 4 is equal to 12. X, 3 minus 1 is equal to 2. So this is the final answer, 12x cubed. So you can try the second example as it just follows the same solution. It's like that. Sum and difference rule. So the sum rule, when you want the derivative of a sum of terms, take the derivative of each term separately. So if we're going to take the derivative of this equation, we should take the derivative of each term separately first. So take the power rule, and then this you can just ignore this. Yeah, you can just ignore that because it's 0, right? Constant, so 0. So if we did this, x6 becomes 6x to the 5th. Yeah, because you will move the exponent. Okay, the same rule applies, same applies, and we will have the final answer. Okay, the difference rule is just the same. If you have a difference, a subtraction instead of a sum, it makes no difference. You still differentiate each term separately. again, we want to do this each term again. So constant multiple rule, our rule first, and then multiply to the constant. Next, our rule, constant multiple rule, and our rule. So this is final answer for that. Now that we have learned what the rules are, we can answer the sample problems. You can pause the video and answer it yourself, and then unpause it if you want to see the answer, or follow me along. So let us begin. We first have to check what rule applies for each term. So for the first term, the rule, our rule applies. So move the exponent to the front. For x, 4 minus 1 is equal to 3. Okay, and then for the second one is the constant multiple rule. So let's first do the sorry about that, the power rule. So 3 negative 3 over 2 go x 3 minus 1. So let's do that. So positive times negative is equal to negative, so let's put negative there. Make this a fraction. So this becomes 3 times 3 negative 9. So 4x cubed is equal to negative 9 over, so 2. There you go. X 3 minus 1 is 2. So that's how you do this. Next term is 2x cubed, which is 2x squared, sorry, which is a constant multiple rule. So again, move the exponent to the front, so it becomes 4. So plus 4x, 2 minus 1 is equal to 1, so we can just, it's invisible. And then x, which is always equal to 1, so plus 1. And then we can just, ignore that because that's just 0. So yeah, doesn't matter. So this is the final answer for that. So if you got it correct, good job. You learned. Okay. For our last problem, we have, what rule is this? This is a power rule, so it's just easy. So move this to the front, 30t, and then 30 minus 1 is equal to 29. So the final answer is 30t, 29. Yeah, that's all. Okay, so you might be wondering why the last problem is easy, because we have already solved the fraction style and sum and difference rule here. So all the rules apply. So yeah, that's all. I hope you learned a lot and you learned how to find what rule applies for each term and how the rules work for the basic differentiation rules. So that's all, and thank you for watching. Bye.